Let us ace our exam like a pro. Here are top derivative questions from the past test papers. Unit 2. We are going to take questions based on the derivative rules, which include the sum rule, the product rule, quotient rule, and the chain rule. 10 questions from the past test papers will help you to prepare for the test and ace it. That's the whole idea. Perfect. In this playlist, you'll find solutions for all the 10 questions. In case you need the PDF, send an email to globalmathinstitute@gmail.com. Follow our playlist to master the strategies and learn more. I'm Anil Kumar sharing with you the solutions of these questions one by one. So let's begin with the very first question now. So normally, when you begin with this test paper, what you notice is the first question is straightforward, knowledge and understanding base, where you have to find the derivatives. Questions are much simpler than what you see here. Well, these are selected few difficult questions from past 10 years of test papers, right? So that's the beauty. So, the very first one is write derivative of following functions with respect to x, right? So that's what it is. F of x equals to square root of x plus square root of x square plus 1. G of x is 3x square minus 1 to the power of pi times 2x plus 3, and h of x equals to square root of x plus 3 over x square minus 1 whole square. Now I've seen from the past test papers where students make mistake and how we can overcome these mistakes. So that is why I am selecting these questions. The very first one is a shocker for many students. They don't really get it. How do we apply the chain rule to get the answer? In the second, we have pi in the exponent, which is a very difficult number to work with, especially at this stage when you begin with calculus. And then we have a radical function, which is 5 to the power of 2. Some students struggle working with uh, these exponents, which are rational in nature. Correct. And that's the reason why these three questions have been taken. Accordingly, my set of 10 actually includes very beautiful questions which will help you understand the topic better, and thereby you will be able to ace your exam like a pro. I hope it makes sense. Perfect. So let's begin with the solution of the very first question, which is right here. We are given f of x equals to square root of x plus square root of x square plus 1. Couple of ways to do it. You could say inside function is u and then apply the chain rule. However, I hope at this stage you know all those things, so we'll go kind of straight. So we are saying the derivative of this particular function, which we need to find with respect to x, is derivative of all this. So as you know, derivative of square root is 1 over 2 square root x, right? So I'll write it straight, which is 1 over 2 square root of x plus square root of x square plus 1. Make sense? Correct. So that's the derivative of the function. Now, we have to times this with the derivative of inside function. The inside function for us is x plus square root of x square plus 1. Make sense? That is the inside function, right? So these are the critical steps involved. So I've skipped one or two right there in the beginning, right? Since I hope you know all that. Correct. So it is 1 over, so I'll repeat this, right? 2 square root of x plus square root of x square plus 1. And what is the derivative of this function? Derivative of this is x derivative is 1. And again, we have square root, right? So square root will be in the denominator. We'll write 2 times square root of whatever it is. x squared plus 1. And we have to multiply it once again with the derivative of inside function. Now, inside function here is x squared plus 1. What is the derivative of this? Well, the derivative of this is 2x. So I'm writing it straight here, right? So saving some space just because I will just put it right there in one sheet. Clear, right? So that's what we did, correct? Now, to just explain to some of our viewers, let us say we have a function y equals to square root of u, right? So some of the students will write this u as to the power of half. And then we'll say, well, y prime, or let's say dy du, right, in this case, will be half of u to the power of minus half, right? And after this, they will write 1 over 2 square root of u. You get this whole idea. So all these steps which you see here uh, are done by the students. No harm doing them, but you see the result, right? So normally when you have a square root function, it is 1 over 2 square root of that, right? As you can see here as a result. Now, the concepts are not very clear to some, and that is why we use this particular method to explain it in more details, right? Explaining more details does not mean that include redundancy in your solutions. Time is precious, and therefore I will suggest follow this method, which is absolutely correct. Do not split these radicals as to the power of half, to the power of minus half, and things like this. Okay, great. So you see, we have here also done a straight thing. We included two steps here. This explanation is important since I've seen students wasting a lot of time in solving test papers, thereby not completing it and missing a question, the last question especially, means you're taking a hit of at least 5%, which is not good enough. So we get to the result simplifying, cancelling out these two 2's gives you the final result, right? So which is 1 over 2 square root of x plus square root of x squared plus 1 times 1 plus x over square root of x squared plus 1. Make sense? So that is the solution of question 1a. If you have any doubts, feel free to write your comments and we are there to support you. And look in the playlist for many other questions. Now, let's look into part B of this question, which is where you get pi in the exponent, right? So, pi is just a number, right? Okay, it's a real number. So, we have g of x equals to 3x squared minus 1 over to the power of pi times 2x plus 3. Product rule will be applied, as you can see, along with the chain rule. So power rule, chain rule, product rule all combined together. So the derivative will be derivative of the first function, which is pi times 3x squared minus 1 to the power of pi minus 1. That's a critical step. Times derivative of inside function. Let me write here very clearly. Inside function is 3x squared minus 1, correct? Times the function which is 2x plus 3, correct? And now we'll add to this the first function times derivative of the second, right? So which is 3x squared minus 1 to the power of pi times derivative of the second straightforward. So 2x plus 3 derivative is 2. So I'm just multiplying it by 2. Makes sense, correct? Okay, great. So we got this. Now let's rewrite the derivative. So we have pi times 3x squared minus 1 to the power of pi minus 1, critical step, times derivative of 3x squared minus 1 is 6x, times 2x plus 1, 2x plus 3, the second function, plus derivative of the second. It's a good practice to write the numbers before. Okay, so we got 2 times 3x squared minus 1 to the power of, you get the whole idea. So that's what we get. Now, at least you can factor out few terms, right? So 2 times 3x squared can be factored out. So I'm changing the ink and writing this step, which is 2, and we have 3x squared minus 1 to the power of pi minus 1. You get the whole idea. We'll factor this out. So since we factored this out on the first term, we have 6 divided by 2 is 3. So we have 3 pi x, right? So we have 3 pi x times 2x plus 3, right? And on this side, we have plus 1. Since we factored out 1 times pi minus 1 was factored out. So we have 3x squared minus 1. 2 is also factored out. You get the whole idea, right? So that is what we get as our answer in the factored form. Most of the time, we do not mention here that simplify fully. If it is mentioned, you may have to go 1 or 2 steps more to write it in more simplified form. However, this is good enough to give you full marks when the question is as it is written here. You get the whole idea, right? So I hope you've understood. You've also understood that it was kind of important to factor, right? That also gives you communication marks, and you don't lose 0.5 if your teacher is slightly strict. Okay, great. So let's now move on to the third question, which is kind of straightforward, but has the radicals involved. And what I've observed is that whenever in any questions the powers are rational in nature, students really some make some mistakes, right? So let me rewrite the question as some of you will like to. So we have square root of something to the power of 5. So that really means that something x plus 3, which is in this case, over x square minus 1 is to the power of 5 by 2. So that is first thing which you need to understand very clearly. So, and it's being written here so that you do not make a basic mistake. Correct? So now we can apply the power rule first and then the chain rule to get the derivative. Correct? So we can write down the derivative. So let me write down the function first in this particular form, which is x plus 3 over x square minus 1 to the power of 5 by 2. Correct. So now we have the function. We'll first apply the power rule, and so the derivative will be what? So derivative of this function will be 5 by 2 times x plus 3 over x square minus 1 to the power of 5 by 2 minus 1, right? So 5 by 2 minus 1 means 2 is a common denominator. Minus 1 means 2 over 2, right? So we get 3 over 2, correct? Is that clear to you? 5 by 2 minus 1, right? So it is 3 over 2. So we subtracted 1 from 5 by 2. Now we have to multiply with the derivative of inside function. You get the whole idea, right? So we have to now multiply with the derivative of the inside function. So what is the inside function? Inside function is x plus 3 over x square minus 1. We can apply the quotient rule, correct? So if you apply the quotient rule, then you get the denominator square, which is x square minus 1 whole square. Derivative of the numerator, which in this case is 1. So we get x square minus 1 here minus the function x plus 3 times the second function derivative, which is 2x. So I hope this step is absolutely clear, right? So that is where you get. So now you see we have 5 by 2 x plus 3 to the by x square minus 1 to the power of 3 by 2 times x square minus 1 minus x plus 3 times 2x over x square minus 1 whole square. Now, if you have to simplify this, you see in the denominator we have x square minus 1 to the power of 3 by 2 and square. So they get added up, right? Correct. So when you add 3 by 2 plus 2, correct, which means what? So, which means you get 2 plus 3 by 2 plus 2, because 2 you have to make a common denominator. You get 7 by 2, right? So let me do that step here, and then I'll leave you that, please. You can further simplify. You get the whole idea, right? So we have 5 by 2 here, And in the numerator, I'm writing x plus 3 to the power of 3 by 2. Correct. And here in the numerator, we'll open this up, x square minus 1 minus. So open this up, which is minus 2x square minus 6x. Correct? Over. We have x square minus 1. So we are doing 2 plus 3 by 2. Let me do it here. 2 plus 3 by 2, right? So it becomes what? 2 times 2 is 4, right? So 4 plus 3 by 2. 7 by 2, correct? So this is especially for those students who are struggling with working with radicals, right? So that is how you're going to simplify it. So I hope it makes sense. The other simplifications are very simple. You can actually figure out what is there in the numerator, that square bracket, simplify, write down your answer. Makes sense, correct? So with that, we have solved the very first question of this particular test. I hope it makes sense, correct? So we have understood strategies of how do we really apply the rules, which are mainly sum rule, product rule, quotient rule, and the chain rule to find the derivatives. Also, we have learned the techniques of simplifying. Many times, these questions, a comment is written there, simplify fully. In that case, the last example could have been slightly more challenging. So, I like you to practice that. I hope it makes sense. Perfect. Now, let us take the next question, and one by one, you'll have solution of all the questions in this particular video. Let's enjoy this journey of learning. You can actually check more solutions of similar questions from the playlist. Great. So, in this video, we'll take solution of question number 4. Others are already solved in the playlist. Here is question number 4. If y equals to square root of 1 plus r square and r equals to t plus 1 over 2t plus 1, then find dy dt at t equals to 1. Now, straight application of chain rule. Let's see what is the efficient way of solving such questions. Now, basically, we need to find the derivative at t equals to 1. We are given y equals to a function of r and r as a function of t, right? So let's relate the two things also. So when we say r is equal to t plus 1 over 2t plus 1, and if t equals to 1, then what is r? R will be 1 plus 1 over 2 times 1 is 2 plus 1, which is 2 over 3. So r is 2 over 3 at t equals to 1. Correct? Now, if that is there, what is y equals to? Let's figure this out also. So y is square root of 1 plus r square, which is square root of 1 plus 2 over 3 whole square, which is, so now you can see 2 over 3 whole square means 4 over 9, right? So we can write this as 9 as common denominator, 9 plus 4 square root. Okay? So y becomes square root of this, which is equal to square root of 13 over 3. So 1/3 of square root of 13. Makes sense. So we have the y value also, correct? 1 plus r square. R was 2 over 3, which we just found. So 2 over 3 is 4 over 9, right? 4 over 9. When you add it to 1, you get 13 over 9 within square root. So square root of 9 is 3. So we got 1 over 3 square root 13. Clear? So now we know at t equals to 1, r is, at t equals to 1, r is 2 over 3 and y is 1/3 of square root 3. Correct. So it's kind of important to do this part first, right? Okay, once we have these initial values, it's a good idea to find the derivatives, correct? So let's begin with y equals to square root of 1 plus r square. That means derivative will be with respect to r, right? So will be 1 over 2 square root of 1 plus r square times derivative of 1 plus r square, which is 2r. So you can simplify this, correct? 2 and 2 cancel. R over 1 plus r square. Correct. Now, interest is to find this derivative at t equals to 1. And we know at t equals to 1, r is 2 by 3. So we'll substitute this value, correct? So we'll write dy dr at t equals to 1 or r equals to 2 by 3. Substituting, we get 2 by 3 over square root of 1 plus 2 by 3 whole square. Correct. Just as we did earlier by finding the value of this, correct? So that gives you 2 by 3, right? I'm writing 2 by 3 here. And this square root, which we figured out earlier, as you can see right here, right, is 1/3 of square root 13, correct? So we can write this as 1/3 of square root 13. So square root 13 will be here and 3 will be there, correct? So this 3 and 3 cancel. You get 2 over square root 13. Is that clear to you? See how the earlier calculation helped us. Perfect. In our calculation moving forward. That's the beauty. And that is how we actually save time by following correct steps. Now let's look into dr dt. Dr dt. Yeah. So r equals to t plus 1 over 2t plus 1. So dr dt, apply the quotient rule. 2t plus 1 whole square. Derivative is 1 for this. We are left with 2t plus 1 minus t plus 1 times the derivative, which is 2. Now we can substitute t equals to 1, right? Let me change the ink. So we'll find dr dt for t equals to 1. So if I put t equals to 1, it becomes what? 2t plus 1. So t is 1. So 2 plus 1 minus 1 plus 1 times 2. Great. Denominator, we get 2 plus 1 whole square. And simplifying, we get what? 2 plus 1 is 3. And on this side, we have 2 times 2, 4 minus, right? So minus 1 on the top. And denominator is 3 square, which is 9. Correct? So we have minus 1 over 9. So far, we have the result, which is dy dr is 2 over square root 13 and dr dt is minus 1 over 9, right? So let's write down the final answer in the next page. So what we have here is, we know dy dr at t equals to 1 is equal to what? And then we also know what is dr dt at t equals to 1, correct? So let's copy these values. 2 over square root 13 minus 1 over 9. So 2 over square root 13 minus 1 over 9. Is that clear to you? So we got both the derivatives. So now let's apply the chain rule, and what we get is this should be dy dt. So we get dy dt at t equals to 1 equals to dy dr at t equals to 1 times dr dt at t equals to 1. Okay? So we have 2 over square root 13 times minus 1 over 9. So our answer is minus 2 over 9 square root 13. Now, you may like to rationalize this, right? So it will be minus 2 square root 13 over 9 times 13. So it is minus 2 square root 13, 9 times 30, 3 times 9, 27 to 11. That becomes the answer of this particular question. You see that. So these final solution, which we are simplifying and writing in a form after rationalizing the denominator, is extremely important. So I hope with this you have understood the strategy of solving this particular problem. Let us now take solution of the next question. Most difficult question which you'll expect in the test paper. Right here before you. Y equals to square root of x plus f of x square minus 1. Find dy dx when x equals to 3, given that f of 8 is 0 and the derivative at 8 is 3. Well, I'm Anil Kumar. Keep watching videos on our playlist where we provide you solutions with your own questions. That really helps. This channel is absolutely free for last 15 years, a path of success for many worldwide. Now let's see, how do we solve this question? So a couple of things. We are given a function. Let's rewrite that first. So we are given y equals to square root of x plus f. So function within a function, right? Okay, great. When x is 3, given that f of 8 is 0 and f prime of 8 is 3, we want to find derivative when x is 3. Okay. So what is y when x is 3? That's kind of important to understand. So if I put x equals to 3 here, in that 3, right? So x equals to 3 here, then y is equal to what? Square root of 3 plus f of 3 square minus 1. So that is why f of 8 is given to us, right? So that is f of 8. So f of 8 is 0. Correct? So that means we are given that the value of the function when x is 3 is basically square root of 3, right? So at x equals to 3, y equals to square root of 3. Since f of 8 is 0, let me write like this. Okay, let's see how useful that is going to be. So we know this, right? Okay, great. Let's find the derivative of this function. So that is to say dy dx of square root function means 1 over 2 square root of this, right? Times the derivative of inside function, which in this case is x plus f of x square minus 1, correct? Now, this derivative is what? So let's rewrite 1 over 2 square root of x plus f of x square minus 1, and the derivative is 1 plus f prime of x square minus 1 times derivative of inside function, which is 2x. So that becomes the derivative, correct? Now we need to find this dy dx at x equals to 3. So let's substitute. So we get 1 over 2 square root 3 plus f of, this is 8, right? We just saw it, correct. It'll be better. So we'll find dy dx at x equals to 3 equals to 1 over, it was 2 times square root of all this, x is 3. So we'll write 3 plus f of 3 square minus 1, correct? Times derivative of this function, which was 1, derivative of this plus derivative of x square, so we'll write 3 square minus 1 times 2 times x, which is 3, correct? This is what we had. Perfect. Easy. So we'll plug in. Now, square root of 3 plus f of 8 times 1 plus f prime of 8 times 6, correct? F of 8 is 0. Times 1 plus f prime of 8 is 3. Let's put brackets here. That's better. So we get our answer, which is 1 over 2 square root 3 times 1 plus 18, which is 19. Correct? So there we go. We can actually now multiply by square root 3 also to get rationalized form, right? So we could rewrite this as 19 times square root 3 over 2 times 3. How did we get that? We'll just multiply by square root 3 and divide by square root 3. It's kind of important to rationalize. Correct. So the answer will be 19 square root 3 over 6. So that is how we are going to solve this particular problem. I hope the steps are absolutely clear. Let us continue with the journey of learning. Here is solution for the next question. So we are now going to look into this application based question, which is right here before you. I am Anil Kumar, and you can always subscribe to my YouTube channel absolutely free for last 15 years. A learning platform for all of us. Keep sharing your suggestions and keep watching our videos. Now here is the question, application of derivatives. A population of raccoons moves into a wooded urban area. At t months, the number of raccoons p can be modeled by p of t equals to 100 plus 30t plus 40 square. Determine the rate at which raccoon population is changing when initial population has doubled in size. Brilliant question. Let's see how do we work on that. So we're given the function of population with time, which is p of t equals to 100 plus 30t plus 4t square. So it says determine the rate at which raccoon population is changing when initial population was doubled. So we have to find initial population, which is p of 0. So if I substitute 0 here, I get 100, correct? Now doubling means when the population becomes 200. So we need to find time when it becomes 200. You get the whole idea. So find t for p of t equals to 100, 200, 100 times 2. Correct. So let's find this. Substituting 200, and we have 100 plus 30t plus 40 square. So that's a quadratic equation to be solved. So we can write 0 equals to, rearrange this, 40 square plus 30t minus, we can write 100 minus 200 first, okay. And then 0 equals to 4t square plus 30t minus 100, correct? 100 minus 2. You can simplify this by dividing by 2. At least you can do that. Okay, minus 15, 50. Okay. So 2t square plus 15t minus 50 now becomes your equation. You need to solve this to find the value of t. So one way is also quadratic formula. You're looking for 2 times 50, which is 100. That is the product of 100 and the sum minus 100 in this case, sum of 15. So 20 and 5 works, right? So we can split this. Let's do it here on the left side. So we can write this as 0 equals to 2t square. So plus 20t minus 5t minus 50. Makes sense? Let's factor this 2t and we get t plus 10 minus 5t plus 10. So t plus 10 is a common factor, 2t minus 5. So t can be minus 10, but t is greater than 0, as you know, right? T is greater than 0 or equal to 0. So we get the second part, which is 2t minus 10. So let's equate 2t minus 5 as equal to 0. So means 2t equals to 5, t equals to 5 by 2, or t equals to 2.5. So we get the time when the population will be doubled, right? Now at this point, we need to find the rate of change. Let's do it. So once again, we have the population given to us as equal to 100 plus 30t plus 4t square. So rate of change will be, this is 0 plus 30 plus 8t. Now we want to find this rate of change at 2.5, correct? 2.5 months. So substitute 2.5 here, 8 times 2.5, which is 30 plus, so 8 times 2, 16 plus 4, 20. So the population size when doubled, which will be after 2.5 months, so rate of change will be so many raccoons per month, right? So many raccoons per month. So that is how we are going to answer this particular question. So I hope these steps are absolutely clear. We will continue with the solution of rest of the questions in this particular video now. In case you have any doubt, feel free to write your comments. We normally answer within 48 hours. Let's enjoy this journey of learning. So let's discuss a problem right here from the past test paper and see how do we solve it, understand all the steps involved, so that if you get a similar question, you can easily solve. Here I am, Anil Kumar. Welcome to my YouTube channel, absolutely free for last 15 years. You post questions and we provide you with solutions. That's how it works. Great. So the question here is, find the equation of the tangent line to the curve y equals to 2 minus square root x times 1 plus square root x plus 3x at a point P, which is 1, 5. So we need to find equation of the tangent line, right? Point is given to us. Correct. So we know the equation of the tangent line is y equals to mx plus b. We could use that form, or we can use the form point slope form. In any case, we need to find the derivative. So let's begin with the derivative of this particular function. So dy dx, or y prime, we can use the product rule. So derivative of the first function, which is 2 minus square root x times 1 plus square root x plus 3x plus the first function, which is 2 minus square root x, times the derivative of the second function. Well, that's the formula you all know, correct? Let's see, how do we apply it in this particular case? So now we get the derivative as square root x. Derivative is 1 over 2 square root x. And minus 1 will give me minus, right? So I'll write minus 1 over 2 square root x. Is that clear to you? Times 1 plus square root x plus 3x plus 2 minus square root x. And this derivative now, derivative of 1 constant 0. So this is 1 over 2 square root x plus 3. Basically, we need to find this slope of tangent line at x equals to 1. So let's find that. So we'll say y prime at x equals to 1. No need to simplify this equation. We just put x equals to 1. So we get minus 1 over 2. This is x is 1. 1 plus 1 plus 3 times 2 minus 1. That's simple, right? Half plus 3. So that gives me minus half. So this is 5 times 1, and there's plus in between, I forgot. Okay, so let me write plus in between. Correct. So we get plus 2 minus 1 is 1 times. So when you add this, 3 times 2, 6 plus 1, 7 by 2. Correct. So we can take half as common, right? So which is equal to, let's say 2 in the denominator minus 5, and this is plus 7, which is 2 over 2, which is 1. So we get the slope of tangent line as 1 in this particular case, and now we can find equation of tangent line, correct? So we know the slope m equals to 1. So let's move on to a fresh page to find the equation of line. So equation of line is y equals to mx plus p. We know m equals to 1 and the point p is 1, 5. Substituting, we get y equals to x plus p. Point is 1 and 5, so 5 equals to 1 plus p. So 5 minus 1 is p, which is 4. So once we know the value of p, the equation is very simple. It is x plus 4, correct? So that is how we find equation of a tangent line at a point given to us on the curve. So I hope the steps are absolutely clear. Feel free to share your views and comments. In case of doubt, ask questions. That is how we learn. Enjoy this journey of learning. Let us now take the next question. We are discussing Unit 2, Derivatives. Now, in derivatives, you learn product rule, quotient rule, and the chain rule. How do we apply chain rule is sometimes challenging. So let's understand the concept of function before getting into derivatives. So based on that, here is a question for you. Determine g of f of 2 if f of x equals to square root of x squared plus 5 and g of x is equal to x squared plus x minus 2. You can always pause the video, answer the question, and then look into my suggestions. Also, have a look at this playlist where we have 10 excellent questions for you to work on. Practicing those will help you to ace your exam like a pro. So let's begin with the solution of this particular question, where we need to find the value of g of f of 2. The functions given to us are f of x equals to square root of x squared plus 5, and g of x is given to us as x squared plus x minus 2. So when you have this function, first is the inside function, right? So we need to start always with the inside function. Let's find what is f of 2. So Let's begin with the inside function f of 2. So what is f of 2? F of 2 is the value of the function when x is 2. So we are going to substitute 2 in the function. So we get 2 squared plus 5, which is square root of 4 plus 5, which is square root of 9, and that is equal to 3. So we know f of 2 is 3, right? So now let's evaluate g of f of 2. That means we are looking for g of f of 2 is 3. That's what it is. So in the given function, substitute 3 for x, we get 3 squared plus 3 minus 2, or 9 plus 3 minus 2, which is 10. 12 minus 2. So we get the value of the function, so we can write down g of f of 2 is equal to 10. Perfect. I hope all the concepts are getting clear as we move along. Feel free to write your comments, share your views. In case of any doubt, you should definitely ask questions. That is how we learn. Let's enjoy this journey of learning with Anil Kumar. Ace your exam like a pro. In this playlist, we are sharing with you excellent questions based on derivatives, Unit 2, where you are going to learn applications. Here is a brilliant question. The graph of f of x equals to ax plus b over x minus 1 times x minus 4 has a horizontal tangent line at 2 minus 1. Find a and b. I am Anil Kumar. Welcome to my YouTube channel. Absolutely free for last 15 years, a learning platform for both of us. Keep sharing and enjoy this journey of learning. Now, this very important test question on calculus derivatives will now be discussed at length. So, we are given the graph of a function. Let's write down the function itself, which is f of x equals to ax plus b over x minus 1 times x minus 4. We need to find the value of a and b, two unknowns. So that means we are looking for two equations. Since we know that the point 2 minus 1 lies on the curve, one equation we can get with the point, and the other one, well, the condition, horizontal tangent at this particular point, means the derivative of this particular function at 2 should be equal to 0. So we have two equations to work with. So now let's get our equations using the point, which is, let's say P is the point which coordinates are 2 minus 1. So f of x is minus 1 when x is equal to 2. So we'll put 2 for x. And that gives us 2 minus 1 times 2 minus 4 in the denominator. So we get minus 1 equals to 2a plus b over 1 time minus 2. So we can cross multiply. Minus 2 times minus 1 becomes plus 2 equals to 2a plus b. So we have a relation here between a and b, that is twice a plus b is equal to 2. This is from the point on the curve. Now we have the second condition, which is horizontal tangent at this point. So let's find the derivative of this particular function. So to find the derivative, uh, f prime of x will be equal to derivative of ax plus b. We are using the quotient rule, is a times x minus 1 times x minus 4 minus ax plus b times the derivative of denominator, where we'll use the product rule. You could actually expand this and then get a simpler equation also. but you could use the product rule. So derivative of x minus 1 is 1 times x minus 4, and then we get minus plus of derivative of the second function times x minus 1, right? So plus derivative of the first function, which is x minus 1, correct? So that's what we get. Denominator is square of all this times x minus 4 whole square. Means, let me square like this. You get the whole idea. Since we are given a point, there's no need to expand, simplify. So let's substitute the value 2 for x. So what do you get? You get a times 2 minus 1 times 2 minus 4 minus 2a plus b times 2 minus 4 plus 2 minus 1. Makes sense? Divided by, substituting 2 will give us 2 minus 1 whole square times 2 minus 4 whole square. Correct. Now this derivative is 0. So 0 equals 2. So forget about the denominator. The numerator should be 0, right? So let's multiply. So a times 2 minus 1 is 1. 2 minus 4 is minus 2. So we get minus 2a minus. So here we have 2a plus b times 2 minus 1 plus 2 minus 4, right? So we get 4 minus 4 minus 1, which is minus 1 for us, correct? So which is minus 1. So let's open this bracket to find our equation. So minus 2a minus 2a, and this minus makes it plus. And we get the value of b here, which is plus b. So minus 2a plus 2a is 0, so b equals to 0. Now, if b equals to 0, we can substitute in our first equation. B equals to 0, find the value of a, right? So let's do that. We'll squeeze it in this particular page itself. So we get 2 equals to 2a, we write plus b, which is 0, right? So dividing, we get from here a equals to 2 divided by 2, which is 1. So we got both the values. Find the values of a and b. So a is 1 and b is equal to 0, right? So for this condition, we got a equals to 1 and b equals to 0. Is that clear to you? That is how we are going to solve this particular problem. So a point where we have a horizontal tangent actually gives us two equations. One, substitute the point in the function itself to get first relation. Second, find the derivative and then substitute the point. That gives you the second condition. Two variables, two equations, you can easily find by elimination or substitution the result. So I hope the whole step is absolutely clear to you. Feel free to write your comments, share your views. In this particular section, I'm going to share with you a very beautiful question, which is seemingly simple from this list of 10, which is find the quadratic curve y equals to ax square plus bx plus c, which passes through 219 and has a horizontal tangent at minus 1, minus 8. Now remember, in this particular function, we are given three unknowns a, b, and c. And if you really want to find exact values of these three unknowns, you should have three equations. So look for the three equations which you can create. Equation number 1 comes from the point given to you, 219. Equation number 2 comes from the second point, which is minus 1 minus 8. From where do you get equation number 3? Well, it is from the horizontal tangent condition. So you have three equations and just find the values of A, B, and C. You can always pause the video and then look into my suggestions. I'm Anil Kumar. You can always join my classes, and here on this platform, which is a learning platform absolutely free for the last 15 years. Keep contributing and keep learning. So let's begin with the solution. Equation is given to us as y equals to ax square plus bx plus c. Now we're going to substitute the values 2 and 19 for x and y, since that is the point on the curve. Let's call this point as point A for now. So 19 is the value of y when x is 2, right? So we can write like this, correct? And that gives you the first equation, which is 19 equals to 4a plus 2b plus c. Now for the second equation, I am going to substitute the point, which is minus 1 minus 8. So that means I'll call this as a point B, right? So minus 8 is the y value and minus 1 is the x value. Correct. So it gives you minus 8 equals to a minus b plus c. Right. So that becomes our second equation. Now, since we have to solve all the three equations, why not start solving right now with these two? So if I do equation 1 minus equation 2, we can get rid of c's. You see that? Correct. So we get 19 minus of minus 8 on the left side. And here we have 4a minus a plus 2b minus of minus b, and c minus c is 0, right? Let me write down c minus c, right? So 19 plus 8 is 27. 3a minus a, 4a minus a is 3a, and 2b minus of minus b is 3b. We can simplify this by dividing by 3. So 9 equals to a plus b. So we'll call this as our equation number 3. Makes sense, right? So we have now a relation between a and b. So a plus b is 9. If a is known to us, we can find b as 9 minus a. Correct. Now let's move forward and use the third condition given to us, which is horizontal tangent. So what's the derivative of this particular function? So let's find dy dx. Derivative will be 2ax plus b. And at x equals to minus 1, we know this should be equal to 0, right? So let's put 0 here, and 2 times a times minus 1 plus b. So 0 equals to minus 2a plus b. Now, so we can call this as our equation number 4. Clearly, we have 9 equals to a plus b and 0 equals to minus 2a plus b. So, if I subtract one from the other, so that is to say, equation 3 minus equation 4, we get what? So, we get equation 3, 9, right? So, let's write down 9 equals to a minus 2a gives you 3a, b minus b is 0. So, we get this, and from here, we now know that a should be equals to 9 by 3, right? So that gives me a equals to 9 by 3, which is 3. So we know the value of a is 3. Let me highlight this. So I've squeezed it in because I want to give you the complete solution on this small space. Perfect. Makes sense, right? Yeah. So now let's move forward. Find what b is. Well, b is 9 minus a, which is 9 minus 3, or 6, correct? So we get the value of b as 6. Now we can find the value of c using one of our equations. A better equation to use is equation number 2, which is minus 8 equals to a minus b plus c, right? So we'll substitute a, b in it and find c. So we have minus 8 equals to a is 3 for us, b is 6 for us, plus c, right? So we have minus 8 equals to minus 3 plus c, or minus 8 plus 3 equals to C, which means that C is equal to minus 5. So we have the value of C as minus 5, and therefore we have our solution. And the quadratic curve is y equals to A being 3, B is 6, and C is minus 5. Makes sense. So that is how we are going to solve this particular question. Neat and clean for you. All the steps have been discussed here, and those of you who are just preparing for the test a day before, for them, it is an excellent playlist. Go through this playlist, understand all the concepts required to ace this particular unit on calculus. Great. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.